Hello, my name is João Roque, and I'm an advocate for automation and connectivity at Critical Manufacturing. Today's topic will be about versioning. Versioning is a very hot topic. There are a lot of different ways to go about it, and today I wanted to kind of give you a bit summary about versioning strategies and basically my own opinion and thoughts about how you should run versioning for critical manufacturing customization projects. It all starts with a box. A box is basically something that I can ship, deliver, and install. As a software engineer, we develop our code, we have Git to control our source code internally, but what happens when we deliver that code? How can we keep track of what we are delivering? Without, of course, having to open it, try to somehow decompile it or compare it against previous versions and understand what's inside. This is where versioning kicks in. Versioning is nothing more than some metadata information that we append to what we are delivering, tagging it with relevant information for our package. In the beginning, or some kind of intuitive approaches to versioning are what I call time-based versioning and sequential versioning. So everyone that has ever built something understands what is sequential versioning. It means that I have the first version, the second version, the third version, and so on and so forth. Normally in software development, you have the underscore new v2 underscore final. So it can be sequential in different ways. But sequentially really means this kind of an iterative approach where you start from one and then you go on and on and on and on. Time-based versioning means something a bit more relevant in terms of context. It says that when was this package created? When was this artifact created? This is helpful sometimes to compare it against, for example, our Git branch, so understanding at what time was that software package generated. But still, it's not that great information. It forces us to have to do some kind of magic correlation to understand what's inside. So we already see here that different types of versioning with different metadata can provide us different context and different information. Semantic versioning has become the de facto standard for software engineering. So there are still some packages that use, for example, time-based versioning, but semantic versioning really has kicked in as something that's very simple to understand, very intuitive, but also brings a lot of information. Semantic version is split into major, minor, and patch versions. So these are 3 digits that provide a lot of information about your package. There are also some add-ons like alpha, beta, release candidates, and so on. But let's focus on this major, minor, and patch version. When we talk about major versions, what we mean is there were some really big changes to your source code that you delivered. So there could have been breaking changes, there could have been infrastructure changes. So for example, imagine that you have an application that depends on SQL Server. It may have changed to MySQL, Postgres, or imagine that you are depending on a transport broker like RabbitMQ and you've changed to Kafka. So major version means that not necessarily I've made breaking changes, but I've made big changes to my code. So beware, I'm signaling to everyone that is using my code, beware that this really had a big change, a big impact. Minor version means I've kept everything backwards compatible, so what you had in the past still works. What I did was I added more functionality. The idea is just to highlight to the users, okay, this shouldn't break anything, so it's made to not break anything, and to add some new features. A patch version is a set of fixes or bug fixing that is being delivered. So we found out some bug, we want to release a patch, and we increment the patch version. So right away, when I come from 0.0.1 and I go to 1.2.10, I know that at least I had one major version, at least I had 2 minor versions, and at least I have 10 patch versions. So what does this mean in an actual use case? So I've built my code. It's called the Mega App Awesome, and I'm depending on some kind of third-party package. So this has become very common in the industry. We can think, for example, in Node.js where you have npm, or some kind of front end where you have npm, and even in .NET where you have Nuggets, or Java where you have Maven. So basically, as software has progressed and become more complex, we are kind of focusing on our core business, delegating everything else or some part of it to third parties. But by doing that, we have to trust their versioning. So we have to know that my super duper code is depending on version 1.0.0. And when I want to release my super duper code version 2, and because I am a responsible developer, I want to update all my dependencies for security reasons, for feature reasons, And I'm looking at my code and I see, okay, I have this dependency, and this dependency has shifted from version 1 to version 5.1.0. So what is my mindset to go about this? My mindset should be, this has 4 times more probability to give me headaches. I know that there has been 4 major version changes, so they really invested a lot on this and probably changed a whole lot of things. I know there has been 1 minor version, so even in version 5, they have added some more functionality. And so I need to really be aware in parts of my code that depend on this, because there may have been really considerable changes. So in terms of testing, I need to really be sure that everything is okay, and probably check the release notes to understand what they have done for all these versions. What about in critical manufacturing world? How do we deal with versioning? In critical, we have our product version and we have our customization version. So our product version follows strict semantic version. We have currently version 11.1.5, so this means that we know that there have been 11 major versions to our product. In version 11, there has been 1 minor version, and there has been 5 patches. For customization, we support CLI, so critical manufacturing CLI, and the CLI already enforces semantic version for you. So when you are creating a new project, you are calling the CMF init command. The CMF init command will create a root package. A root package is something that is installable by the MES, and that root package will have a version. And in here, you have to make a decision. I know that some people start at version 1. For me, that is incorrect. People should start at version 0.0.1, particularly because when you are in the first sprints, you are changing everything, you are being fast-paced, so you are actually in a version 0 kind of mindset, where you don't know really where you are going, and you are making fast-paced decisions. And in terms of version, strictly, this is what is correct. Okay, so you are in kind of a beta phase where you are in a version 0. So when I look at a version 0, my expectation is that there can be a lot of changes. When I look at version 1, I'm expecting semantic version to be strictly followed. So let's see at the use case of this. So in this first use case, I have 2 requirements. I want to create a new custom service, so I want to add business logic to the MES, and I want to add some master data. So this is kind of a normal requirement when you are building customization. So you want to create a new data package for your master data, you call CMF new data. And you want to create a new business package, you'll call CMF new business. Here it's pretty straightforward, so everything is consistent. So you've created your root packages, these are the first packages. And of course, when you deliver the root package, it will be straightforward. It will be version 0.0.1 with 2 packages, data and business in version 0.0.1. So in Sprint 2, this is where things start to become a bit more tricky. So let's see what are our requirements for Sprint 2. In Sprint 2, we want to have a Connect IoT integration, and I want to make a change to my service that I did in Sprint 01. So basically, I will bump my root package, so I will increment the version of my root package. I will create a new IoT package. So IoT is a bit of a special case where the CLI creates more than 1 package, but let's assume that it creates only 1. This is the first point where things start to become tricky. So when you do CMF new IoT, what should be the version to give to that package? I know that some people have this tendency to want to maintain all versioning consistent. So they want the root package to be consistent with all the packages under that tree. And honestly, for me, that is correct. So what you are doing is you are invalidating the versioning throughout your whole tree. What you are saying is that independently of having changes or not, you are going to bump everything. Don't do this, please. When I see a version change, it implies that there has been a change to the actual source code. If there has been no change to the actual source code, you shouldn't bump anything. And the versioning refers to the package itself. It doesn't refer to all the upwards tree. So if this is my first version of the CMF new IoT package, it should of course be version 0.0.1 because that's the first version of that package in particular. We could have a root package that it was in version 10, and I will still give version 0.0.1 to my IoT package because this is the first version of that package. What is actually inside the package that I generated calling the CMF pack commands? This is where things start to become tricky, and it depends a bit on how you want to handle your versioning. There are 2 ways of handling versioning. One is cumulative deployment, and the other is non-cumulative deployment. When you're doing cumulative deployments, what this means is that your version, your root package version, so it's in this case 0.0.2, actually depends on your previous root package. So in this case, version 0.0.1. And of course, if you go to version 100 of your root package, it will depend on the 99 previous versions of that package. Non-cumulative deployment, you actually flatten your tree. So what you're saying is that I have a root package that is in version 0.0.2, but it depends on all the sub-packages in their current versions. When should you use one or the other? Depends a bit on how you are handling your customization code. Of course, after going to production, you are always installing in a database that has already information. So you need to do, of course, cumulative deployments. Non-cumulative deployments are great when you can clean everything and install from scratch. So you are guaranteeing that every time you are installing in a clean system, so similar to what we'll have when you want to go to production, where you have a clean system and you want to do an installation from scratch. An important question here is that the database is actually keeping track of all of this. So your database knows what were the packages that were installed. So for example, if in my first sprint I did an installation of version 0.0.1 and I want to keep my database, when I install version 0.0.2, it will actually know that I have installed version 0.0.1 and will only install version 0.0.2. Okay, so basically the database is enforcing that you can't override previous installed versions. Okay, so you can only install forward. So let's see an example of this in a project. And actually, I think this is a very pertinent question. So when should a major change when you're talking about customization? So I've been saying that you are starting from zero, you are incrementing your patch or even your minor, but when do you go to V1? In my perspective, and this is kind of a personal opinion or how I handle this in my own projects, I prefer to go with starting a project with version 0.0.1. I go with non-cumulative deployment, so I'm always guaranteeing that I'm installing in a clean database, like I'm going to do in the first time in production. And also here's an important point, which is if I am doing a cumulative deployment, I need to make sure that everything that I'm delivering in Sprint 2 works somehow with what was delivered in Sprint 1. What this means is that if I'm installing things in Sprint 1 that I need to change in Sprint 2, I need to make sure that those things are changeable. So for example, if in Sprint 1 I've created an entity, and in Sprint 9 I've decided that that was kind of a mistake or a bad decision in terms of architecture and I want to change to something else, if I don't clean that entity from the system, when I do my installation, in my production installation, that entity will exist because at Sprint 2 time, it was deployed. So this is kind of a pitfall of doing cumulative deployments. Sometimes it's how it is, so there's no going back. But that's why I prefer to do non-cumulative deployments, at least when I'm in version 0, where I'm still not sure where we are going. I'm still changing a lot. There's still a lot of trying to understand what are the solutions to the problems. So that's why I prefer to go in non-cumulative deployments first. When I do my first go live, I'm going to V1. So when I see a package called V1, I'm expecting that that package, at least in some shop floor around the world, has been deployed. Then we follow strict semantic version. So we do cumulative deployments, and if I have a fix, I'm going to do a patch. If I have additional functionality, I'm going to do a minor. And then, when should I bump the major again? Depends a bit. Normally, it can be, of course, some major change in terms of the customization. My experience is that that's quite rare. So people normally don't do those big changes in customization that strictly enforce a major. What I see more is when you are going to a different major of the MES. So imagine that you are shipping in version 11.0 of the MES, your customization, but then you want to go to version 12, and you have to update your whole customization project to version 12. For me, this would be a major change. Final remarks. Please don't bump things that haven't been changed. So this is very important. Try to follow semantic versioning because it helps a lot to understand throughout time what were the packages, what changed. And that's it. Thank you.